so we're going to be talking about our experience using Scala at Spotify. We've been using it for quite some time now, so I'm sure nothing we're going to say is really groundbreaking, but anyway, maybe it might be of interest. Filipe, can you go to the next slide? So, hey, I'm Julien. I'm a data engineer at Spotify. I've been working with Spotify for the last 3 years. In my career, I think I've used Scala for the last probably 10, 11, 12 years, something like that. Yeah, I'm very old. But yeah, I'm now a data engineer for Data and Insight, and we're the team or the department that builds the infrastructure and the product that people are using Spotify to build data processing jobs.
Hello, and I'm Filipe Regadas. Been a little bit over with Spotify for a little bit over 5 years now. And I work with Julien in the same team, solving the same kind of problems. And yeah, I think I've been roughly using Scala for probably about the same time. I want to first apologize because it's almost my lunchtime for my daughter. So you might be greeted with the Baby Will Cry single. So apologies in advance. But yeah, let's talk a little bit about Spotify. Is Marcin, I think I pronounced it correctly, introduced. It's a yeah, thank you. It's a well-known service for audio streaming. And we do have currently more than 345 million monthly active users. What this means is that within like 30 days, we have users that consume at least once content from the platform. We do have more than 155 million subscribers, which means users that actually pay for the service. And we do have a catalog with over than 70 million songs, with more than 4 billion playlists, and we are now on 93 markets. So this should give you like a rough idea of the dimension of Spotify currently. And, you know, Spotify is actually supported by, you know, a lot of products. Some of them are user facing, some of them are internal, but they all contribute to, you know, the greater good, which is like providing a really nice user experience and a really nice service to use. Some of these services you might already know, or products that you might already know, which is like Discover Weekly, which is like a weekly generated playlist based on your listening taste that allows you to discover new tracks. Your Year Wrapped campaign, which basically generates stats based on your listening history over the year. Then you have Fan Insights, which basically allows artists to actually grasp their fan base and give them some stats about how can they reach more fans, how they consume content, and so on and so on. And then we have, you know, some internal products that contribute to overall experience, but they are like internally used, which is like we do anonymization, which basically, you know, anonymizes all user data. We do fraud detection. And one common thing about all these products is that they are very data hungry. So there's a lot of data processing going on behind the scenes. And one example is actually the Your Year Wrapped campaign, which actually it's one of the largest data processing jobs, I think, in Europe, that actually goes over all year worth of data of Spotify. So basically it processes this for all entire user base, and it's very, very resource heavy. So talking about data processing at Spotify, this is a fun thing because data processing at Spotify evolved a lot. It evolved with Spotify to actually, you know, support the growth and actually be a platform for future growth. So as you can see, there's a lot of stuff going on this slide, but, you know, going back to 2015, we see that Spotify grew from 68 million monthly active users to 345 million active users as of today. And in the course of these, you know, these years, we did have a lot of changes under our data processing strategy. We went from on-prem Hadoop cluster that was the biggest in Europe, at least this is our claim, nobody actually said otherwise. It had like more than 2,000 nodes. And we went from the on-prem to a cloud provider. We did process back then in 2015 around like 2,000 unique pipelines with 20K executions a day to almost 11,000 unique data pipelines and 60,000 execution per days. The amount of data that we processed back then was like around 100 terabytes a day, and now it's rounding to like it's petabytes of data that we process every day. And we do, as of today, we do process like more or less like almost 800 billion events per day. These are events that are sent from the clients, like you played this track, and that's how we actually compensate the artists. Yeah, and as of today, back then we used to have mainly batch data processing jobs, and today we are both batch and streaming. So one fun fact about this, these years, is that the move from on-prem cluster to a cloud provider is that back then we were almost running out of physical space in our data centers, and in order to support the growth, we actually had to make a move, and we wanted to mostly focus on our product to actually propel the Spotify growth. So one other thing that this is all interesting, and that there's more story behind the scenes, and we would happily talk about it later. But one thing that actually changed throughout the years is that our user base that actually does data processing, and by users here I mean like employees, the number of employees grew quite big. It's quite big these days, and right now we have like more than 900 users on the data support channel, and we have more than 500 users on the Scala channel. And you might think like, okay, like these users actually are like data engineers, but not really. We do have like at least 3 segments of types of people doing data processing jobs at Spotify, and they all have different backgrounds, they have different expectations, they have different use cases. And actually one user segment that we miss here is actually machine learning engineers that also do data processing for feature extraction. But our data processing platform had to evolve to actually support all these types of user segments and have like a common platform that users can rely on and be consistent across the company. So on that matter, one thing that you probably noticed on the slide before is that we were experimenting with a lot of technologies, and initially we were on a Hadoop. We were using Apache Crunch, which is a Java data processing framework. Then we kind of slowly transitioned to cascading. We had like some use cases using cascading. Then we started experimenting with Scala, so Scalding came along. We did some experimentation with Spark. It didn't really work out for us that well. And then we transitioned from, finally to our own data processing framework, which Martin already mentioned. Sorry, Scio. So as you can see, like we slowly transitioned from Java to Scala. And so a little word about Scio, our final take on data processing. So Scio is a Scala, it's our own open source Scala API for data processing that's based on Apache Beam. And Scio lets you unify batch and streaming data pipelines and allows you to actually support different execution engines. Because it means that with little or no change, you're able to run your job on Dataflow, Spark, Flink. There are, as usual, some execution engines that are more support than others, but overall, they work decently. On the left side, you can see a small example of a Scio job. It's a very naive word count example, but you can see like how concise it is. So you might now think like, okay, so you moved from Java to Scala, but okay, why Scala? Okay, these are the obvious bullet points, and Scala, it can be immutable by default. When you talk about data processing, there's always a distributed system backing it up. So having immutable types makes it easy to reason about computation steps. You have like a strong type system, which allows us to reason about transformations, because ultimately in a data processing job, you're mostly transforming data type A into data type B. And having a strong type system helps us reason about all these transformations in between, how you can go from A to B, while helping users not commit a lot of errors and reason about them better. You can also have like the JVM ecosystem. You can tap into it. You do have like good tooling, good libraries, and Scala can ultimately be performance. You might raise, some of you might raise, an eyebrows on this, but data processing can be expensive. And Scala has a few tricks in its sleeve, and we can actually make it performant enough. So yeah, these are like the normal bullet points. But one thing that Scala is going for it, and it has a lot of other features that allow us to expose its expressives. And on the left side, here in these two examples, you can see like the Scio example, Scala based, and on the right side you can see a Beam example, which is Java based, and they both represent like a naive word count. But you can see that on the left side we have a more expressive and more intuitive. And what I mean by expressive is that users are able to actually express the computations over a specific collection more easily through the application of functions. It's more natural, and it's easy for even for users new to Scala to come in and actually look at the example and realize, okay, this is doing this. While on the right side, even though it looks, one can actually, if we squint a bit, we can understand, but there's more to it. There's more metadata. There's more types to actually circumvent. There's more ceremony going on, and requires a more understanding of the actual framework to actually do a job. One other thing that Scala has is a very good Scala compiler. And what I mean by very good is that it has like a lot of features going for it, and we can leverage them to actually achieve some good things like ease of use, reliability. So let's dissect this example here a little bit. Here we have a small job that actually reads from BigQuery to does some transformation there, does an aggregation, and writes it back to BigQuery again. But one thing we can see from this is that we are using user-defined data types, and those data types are actually mapped directly to BigQuery types. So in this case, when we read from BigQuery, we are actually mapping the row data type to an actual underlying row in BigQuery expressed by that SQL query. So in this case, we are actually using macro annotations to actually derive the SQL query, the BigQuery SQL query, to a case class. And this, for users, it's very practical and very easy to use because users don't actually need to manually handcraft their mapping code, and it can be very error prone. And this also, because it's generated at compile time, we can actually cross-check if, for example, a user changes the query, the build will fail because it will be statically checked. The same thing will happen on the right. We do have like the result data type there, but it does the opposite. We actually, from the case class there, we actually derive the table schema that you want to write in. So yeah, this makes it, handling BigQuery queries and writing BigQuery very easily. And BigQuery is just an example. We do have like macro annotations for other data types like Parquet, Arrow. Yeah, it makes it very, very straightforward to use. One other thing that it's kind of hand waved here is that we are doing data processing. So with this, we can handle petabytes of data. And, as I mentioned before, data processing is a distributed system behind the scenes in any shape or form. And with any, distributed system, you need to handle serialization. And here we don't see any, the serialization is not really exposed to the user. The user is free from it. And what we do is that we actually use a type class called coder that actually handles the serialization of user-defined types. And that type class is actually derived at compile time. This derivation can be, for specific types, it's highly optimized to decrease the serialization time. And it frees also the user from handcrafting their own serialization, which can lead to huge bugs. So yeah, these kinds of features that we can leverage from Scala C actually allow us to, define jobs that are, good for users coming to Scala, to users that are very senior with Scala, because you can grow from here. So at this point, like we are, we see that we are like heavily invested in Scala, and we can leverage all of these features to actually give like a really nice user experience. So at Spotify, Scala is actually, at the core of data engineering. Like it's the de facto language that we use, and by extension, Scio. And then, as I mentioned before, there's this amount of users using it every day. And because we are so invested in Scala, we like to contribute back to the community. And we are a member of the Scala Center Advisory Board. We tend to help out libraries that we highly use, like Twitter, Algebra, Chill, SVG Plugins. We try to contribute back and help out as much as we can. And another way we can help out is actually by open sourcing our libraries. We do have a lot of libraries that we use in our data processing ecosystem, also in machine learning, like Featuring, for example, for feature transformation. We do have like Magnolify, which allows you to easily convert between data types. We have a lot of libraries for data validation and data sampling. Yeah, we have more libraries. This is just the, just a glimpse. So if you are in this space and you feel like you are facing some issues, when you want like, some good libraries to start, please check them out under the GitHub Spotify org. So I guess this is all I have to say right now. I'm gonna hand it over to Julien.
Yeah. Thank you, Filipe. Yeah, so that was why we choose to use Scala in the first place. But now let's have a little look at where we are now and how we feel about it after 6 years of using Scio in production and even more years of using Scala. Next slide, please. Right, so for the most part, and you probably guessed it, we're pretty happy about it. Scala does deliver on all the qualities that we were expecting from it. So, and given the name of the conference, I'm sure you guys agree that Scala is a great language. So we're not going to talk too much about that since everyone's in agreement here. But let's talk about the things that actually are a bit problematic. Well, the first one is that hiring Scala engineer is hard. That's not exactly a surprise, is it? Any hiring of a software engineer is hard, or at least that's been my experience in various languages for the last 10 years. And on top of that, we're doing data engineering, so it's a niche in software engineering, so we have even less people with experience to tap into, and people are not used to Scala even in the data engineering domain. So basically, the bottom line of that is, can you come back a little bit, is that no one will have experience with our stack. No one will use exactly the same software stack that we use at Spotify to do data processing. No one will use Scala and Scio and Luigi and GCP and Stix and this and that. So we can't really hope to hire someone and they can just work with us and be fine. So next slide. So what we do is that we train people. So we have this data engineering training internally at Spotify. We never train people to Scala specifically. That's just something that's not sustainable. We can't just like train people to use every tool individually, and Scala is just a tool in the chain. So what we do is that we train data engineers to do data engineering. So if you join Scala as a data engineer and you don't have any Spotify, sorry, as a data engineer and you don't have any experiences in Scala, what you're going to do is that you're going to be trained to write a data pipeline and deploy it at Spotify. And what that means is that you're going to be writing Scala code. So you're going to be learning about Scala that way. We do have two ways to do this. The first one is something called the Golden Pass. It exists for every domain of engineering at Spotify, but we have the Golden Pass for data engineering. And what that is a very long tutorial about writing a pipeline starting from zero and deploying it in production and testing it and making sure it works and monitoring it at Spotify. So it's very specific to the Spotify stack. But if you go through it, if you follow the tutorial by yourself, which you can do, you would probably take like 3, 4, 5 days to go through the totality of it. But by the end of it, you've deployed an actual pipeline that processes a fair amount of data. We also have something called tech universities. So again, it applies to every domain of engineering at Spotify. We have tech universities for data engineering, of course. And what that is that it is usually 1 week trainings with people teaching you how to do things. And the people who are teaching you how to do things are actual engineers who write code and deploy it to production. It's not just people who train people to, their job is not to only train people. When it comes to data engineering, we have a bunch of those, I think 3 or 4 universities, and it goes from the very basics of writing a data pipeline and deploying it to more advanced topic, like how to profile and optimize big data pipelines. Right, so that was one problem, how we tried to solve it. We have another issue after a few years. Filipe was talking about the fact that we have backend engineers, ML engineers, data engineers, and data scientists using Scio and doing data processing. And the fact is, data scientists don't like Scala. And I don't think there's much we can do about it. It's just too unfamiliar. It's just too technical for people who are not exactly engineers, but more into math and science in general. And for them, the programming language is really just a tool to experiment. It's really different from Python. Type system, it's not dynamic. It has a lot of wild features, and usually those people, they know either Python or R and SQL, but like that's just way out of what they used to. The feedback loop is a bit slower than with dynamic languages like Python or R because of the compiler and because of other issues inherent to data processing. That's pretty bad for them, because usually what they want is like write a bit of code and try and see what it does and then iterate on that. And it has many, many confusing features like implicits. What is that even? So it's never gonna work for them. On top of that, Scala for us has a bunch of technical issues that gets in the way of us doing a job, and we're gonna try to see if we can fix them and what they are. Okay, next slide. Serialization issue. Wow, that's a new one. No, it's not. It's been there forever. Well, of course, it's not specific to Scala. If you use a JVM, you have serialization issues all the time, especially if you're doing data processing. Scala makes it a bit worse, though, because it's functional in nature. So we're going to have closure everywhere, and closure, as you know, capture the scope. So you're going to have to serialize a bunch of stuff that we're not expecting to serialize, which is going to cause issues when you deploy your code in a distributed system. One of the worst problem with that is that it leaks implementation details, because essentially when you have a stack trace, because of serialization issue, to fix it, you have to understand why it came to be. So you have to understand why the framework is trying to serialize your closure, and then why it's capturing, and why that thing doesn't serialize. So in the end, you're exposed to the fact that things in your test framework don't serialize, because when you write your test, Scio actually will create do-fun, which is a distributed function, and that thing captures the scope, and the scope is capturing the test framework, and the test framework doesn't serialize. There's nothing we can do about it. That's too bad. Really nothing technically. So what we try to do is that when people run into that issue, we explain to them why that's happening and how they can fix it. And that's it. That's a bit annoying. All right, let's talk about another issue that we have, binary compats. Again, a very new issue that no one ever had before. No, not true. I've seen that in Scala since, I don't know, first time I used it, probably. But yeah, so internally we support Scala 2.12 and 2.13. That's a bit annoying because all the libraries that we have internally and externally at Spotify have to be cross-published for the 2 version, which of course is a lot of work to maintain. Internally, we have about 95% of our job that are still running on 2.12. We support 2.13, but people are just not migrating, and we're not creating new projects through certain just yet. And why is that? Is because migrating to a new version of Scala actually takes time. And you know, when you're writing a data processing job, you're focused on writing your data processing job, and you want to deliver value for the company with your job. You're not interested in the language that he uses, or the version of the language that he uses. That's far down the line when it comes to priorities. So why would you migrate when your job is deployed and has been deployed in production for the last 3 years and it works just fine? Why would you take the risk to break things and deploy a new version just because you want the new shiny version of Scala? And of course, Scala 3 is coming soon. And that means that, what do we do now? Do we support 2.12 and 2.13 and Scala 3? That's going to be a lot of work. Do we drop support for 2.12? Yeah, that's not happening. So yeah, it's pretty scary, at least. We don't have a plan for now and how to fix this. Next slide. We also have, because of that, we also have issues like fragmentation in the community. Some libraries are published as soon as a new version is there, and some are not. The breaking change means that people are less willing over time to actually do the migration because it takes work and it might break their code. Libraries end up being unmaintained. And also when a new version is published, everyone has to republish the libraries. So it's just like work that falls on you and you have to do it at a given time, which is extremely annoying when you're trying to plan the next months of work. Next. Dependency conflict, again, not specific to Scala, but it's annoying. I have a small example here where you use Scio to resolve one library, and that library is pulling 6 different versions of gRPC. And at that point, we're not even trying to use 2 libraries, but we already have a conflict. And why is that happening is because all the Java libraries, or most of them, are meant or tested with Maven. So if you use Maven, that's fine, it's going to work. But we're using SBT and Scio, so it doesn't work the same. So we're running into issues that are already solved normally by the maintainer of the library, but we just run into that. There's some stuff happening in SBT version localization. Maybe that would help. a few months ago, we submitted a proposal to the Scala Center to improve the situation a little bit, and they created the SVG plugin for that. Next. Okay, so what do we do at Spotify to address those? We mainly have two things up sleeves that we try to do. The first one is that all the internal libraries are published in a monorepo. It's not a big one. Don't be scared by the word monorepo. We have, I think, 20 or 30 libraries internally that most people will use to do data engineering. They're both Java and Scala libraries. But the reason why we do this is that because if you have all your libraries in the same repository, then you can do an atomic publish. So when a new changes needs to be published in a library, we republish everything with the same version number. Each library is owned by a different team, but my team, Flatmap, and Filipe's team is owning the build of the repo. And that makes actually cross-publishing easier because that means we can actually migrate and make pull requests on other libraries so that people can just like do the migration. More importantly, it gives us consistency. And compatibility. So we know that all the libraries for any given version, they all share the version number. So you have guaranteed that those libraries not only work together, but also their transitive dependencies are working together. So people who are using that, they just use the same version everywhere, and they're good. They know it's going to work. There's no conflict or anything because we tested it. It also means that we have less configuration possible in projects Spotify because people are using one version of that library, and we know that all the transitive dependencies are consistent across projects, which is pretty good. Next was another thing, which is pretty nice, the SVG plugin. So we have internally custom SVG plugin, and what that does is that it sets up the basics settings that your project need, and it's pretty much anything like it package, it set up the test framework, configuration, your Scala flags, yeah, you name it. That again helps with solving the dependency conflict because what people do is that they just upgrade the version of the plugin and then it upgrades everything. That includes the library they're using, the internal libraries, the transitive dependencies, the version of Java, the Docker image, yeah, whatever. Everything is upgraded version of Python. It creates a separation between the things that are common to every project to Spotify and the things that are custom to a project, so that when we need to change the build, it's actually easier because we're not we don't end up in a state where people don't really know or don't remember whether something in the build is custom to their project or it's actually like basic stuff that every Spotify project uses. It lives in the same monorepo as all the libraries, so it shares the version number scheme. And yeah, it makes everything easier to upgrade, especially to upgrade automatically with Scala Steward, because instead of having to upgrade all the libraries, you just upgrade the one plugin, and that means that Scala Steward makes one pull request. Yeah, that's a lot easier. So we're running a little bit out of time, but a few words about the future. Scala 3, yeah or nay, are we happy about it? Well, let's look. First of all, yes, we're excited about it. Overall, it looks really nice. It has really exciting stuff. And Filipe and I are Scala nerds. We've been using for 10 years. So like, yeah, we're excited about match types and advanced stuff. That's new types, union types. Cool, type consideration, yay, better macros, tasty, universal equality. All those things are really nice. The runtime multi-state programming is pretty cool. It means that maybe we're going to leverage that to implement optimization, even though right now I'm not sure how, but that looks awesome. But it's also a little bit worrying because some of the changes are hard to justify. For example, when the keywords are changing, yes, it's cool. Yeah, we know it probably makes the code a little easier to read. And yes, we can migrate automatically with ScalaFix, but that also means that all 500 engineers now have to learn about new keywords. And there's a human aspect to it. It's not only about techniques. People have to learn stuff, and they have other things to do with their lives. Not everyone's a programming language nerd. So, you know, sometimes people just want to ship a new version of their pipeline. The changes like wildcard import, I know with star instead of underscore, that's the same vein. It's very simple, very easy, but all those little changes, they add up all the time, and it makes the code confusing when they already know Scala 2. So yeah, those are kind of hard to justify. Like, yes, some of the features like the better macro system is a breaking change, but also it adds a lot of values. But changing a keyword, does it add a lot of values? Maybe not. So we're not clear about that yet. What else do we have to say? the adoption will be slow. That's sure. When we migrated from 2.12 to 2.13 or supported 2.13, it took us a lot of time because you need your dependencies to be published to the new version. And for us, it was actually pretty hard. We had to support 2.13, go out and make PR in various open source projects so that they would support 2.13 too. I'm sure we're going to have to do the same with Scala 3. And that's a lot of work. And again, we have other things to do with our lives. Maybe the with.t compat is going to help because libraries that support 2.13 can be used in Scala 3 projects. But that's not really something you should be using in a library, because otherwise you create a bigger mess in terms of conflict in dependencies. It's going to create more fragmentation internally because we're going to have projects using 2.11 still, 2.12, 2.13, and now Scala 3. Great. It's pretty clear that some pipelines will never be upgraded to the newer version. We still have pipelines running Scala 2.11 because people don't want to touch them. And so the question is, should we migrate? Realistically, when you're going to see people and then go and see people and tell them, yeah, look, Scala 3 is out, we support it, use it, it's great. They're going to tell us, why should I spend some time working on that? What is the added value? And that's a fair point to make. Why are you winning when you actually upgrade Scala? Why should you spend a week of engineering upgrading your project? We're going to have to be very convincing with this. I'm not completely sure how we're going to do this. Okay, and that's going to be my final slide then. We're actually trying to help. We're not complaining only. Spotify is a member of the Scala Center advisory board. That means we give our opinions about stuff, but also we are financially supporting the Scala Center. We had a little bit of a collaboration with the Scala Center to test Scio on Scala 3 and try to migrate and see what was hard and what would be broken. We created a bunch of bug reports on the migration guide, on the Scala compiler, and other projects. We're trying to give feedback. And when something is not supported, we try to find alternative with the Scala Center, and hopefully that could help the rest of the community and sort of be an example of a project, a fairly big project that has migrated to Scala 3 once we've made it. And so people can look into and steal our ideas. Right, that's going to be it. I'm way out of time. Go check out our stuff. Spotify is hiring. Go to Spotify job. I want to mention that now Spotify actually is open to remote job positions, and that's a new thing from last week. So I'm sure some of you guys are going to be interested. Anyway, that was all I have, and I think we can now move to questions.